Okay, thank you for being around once again, and we will be discussing a logarithmic differentiation. Now, logarithmic differentiation is actually a method of finding the derivative of functions expressed as product, quotient, powers, or roots of two or more differentiable functions in x. Now, we are given steps on how to solve the derivative of the function using the logarithmic differentiation. Now, take the natural logarithm on both sides of the given functions. Second, you have to simplify the right-hand member of the equation using the properties of logarithm. Then you have to differentiate and obtain the y prime. And of course, you have to give your y prime in a simplified form. Now, you are given a function and you are asked to differentiate using the logarithmic differentiation. Now, your y is expressed as a product of a fourth root of a 5x minus 1 and a cube of 3x plus 2. Okay, so here we have the solution using the logarithmic differentiation following the steps. No? Then I have to take the natural logarithm on both sides of my equation. Then I have to simplify. There I have ln y, and the ln of the product of the fourth root of 5x minus 1 multiplied with a cube of 3x plus 2. So I have the ln of the 5x minus 1 raised to power 1/4. So if that is expressed as a product, I can have this be written as sum of two logarithmic terms. So we have plus the ln of 3x plus 2 cube. Now, you can further simplify using another property of logarithm by expressing the power as a factor. So we have 1/4 ln of 5x minus 1 plus 3 ln of 3x plus 2. Now, if you reach a logarithm of a function where your u is raised to a power 1 exactly, so that means that under this equation here, so this is already ready for differentiation. So I can differentiate to solve for my y prime. Derivative of ln y will give you the 1 over y prime following the rule for the derivative of ln u, which is equal to 1 over u du dx. So 1/4 times the 1 over 5x minus 1. 5 is actually the derivative of 5x minus 1 plus 3. 1 over 3x plus 2 times 3. Okay, so there we have the LCD in order to combine this into one fractional term. So for 5x minus 1 with 3x plus 2 as my LCD divided by this denominator. So these two factors are out. So what is left is 3x plus 2 multiplied with 5. Plus, we have 9. And if we remove the 3x plus 2, so what is left is 36 times the 5x minus 1. So, perform the operations in a term. No? So, we have 15x plus 10. Then plus 36 times 5 is 180x minus 36. So, your x term is actually 180 plus 15x. No? So, we have 195x minus 10 minus 36 is minus 26 over the LCD. Now, in order to solve for the y prime, then I have to multiply with y prime both sides. And the result would be, so we were able to have the ratio multiplied with y, and my y can be replaced with the given. No? So, which is the fourth root of 5x minus 1 and the cube of 3x plus 2. And I have to let my 5x minus 1 to appear once because this is appearing in duplication. So, combining them as 1. So, this is containing a power 1 while this is having a power of 1/4. So, 1 will be subtracted with 1/4 and I can have the 5x minus 1 be placed in the denominator so that the power of which can be a positive exponent. Now, the 3x plus 2 also appears twice with a power of 3 and 1. So, 3 will be reduced by 1. So, we have 3x plus 2 squared belonging to the numerator side. And the y prime is arrived, which is this one. So, we have a y prime equal to a ratio where the numerator is a product of 195x minus 26 multiplied with the square of 3x plus 2 and it's divided with 4 multiplied with 5x minus 1 raised to power of 3/4. Now, number 2 is in a form of a ratio. So, we are actually having three function, a function in x. Okay, so as a ratio, so we can have a logarithm both sides, a natural logarithm on both sides of the given. Then I can simplify my right end. No? So in a form of u over v, so we can have a difference of two logarithmic terms. We have a logarithm of the numerator side minus the logarithm of the denominator side. My denominator is expressed as a product, so we can break that or express that into sum of two logarithmic terms. Further simplify by allowing the power to be expressed as a factor. So we have 3 ln of x plus 1. So we have 1/2 of ln x. That's negative because it's preceded with a negative because they are part of the expression in the denominator of the ratio. So plus becomes minus. So minus 2 ln of 7x minus 4. So all powers are now equal to 1 for your ln u form. So ang imong u karon already contains power which are actually 1. So it's now ready for differentiation. Taking the derivative with respect to x for every term, so we have 1 over y prime equal to 3 multiplied with 1 over x plus 1, then minus 1/2. So we have the derivative of ln x, so we have 1 over x minus 2. 1 over 7x minus 4 times 7. So, expressing this as one fractional term, I collected the factors of my denominator. We have 2x, x plus 1, then 7x minus 4. Divide with x plus 1, so we have 2x with 7x minus 4 multiplied to 3, so 6x with 7x minus 4. My middle term. So, what is left is the product of these two binomials. So, 2x is out, no? So, we have x plus 1 multiplied with 7x minus 4, no? Then, I have 14 times 2x. So, we have 28x multiplied with x plus 1. So, perform the operations in the numerator side. We have 42x squared from the first term minus 24x. So, a product of this binomial, we have x squared, 7x squared mn. We have x term, 7x minus 4x, 3x, correct? Then minus 4, preceded with negative, and I can distribute also minus 28x to x plus 1. So, 28x squared, negative, minus 28x, no? Combining all the x squared term. Okay, so there I have the 7x squared. X term is also combined, no? So, there I have minus 55x plus 4, no? Then, over the LCD. I multiply with y to arrive with the y prime. And I know that my y is the given. Okay, so simplifying. So, x plus 1 cube, and this is x plus 1 with a power of 1. So, x plus 1 squared is at the numerator side, no? Then, the 7x minus 4 all belongs to the denominator side with the power which is now 1 and 2 added. So, cube, no? And x with power 1 and 1/2 are also combined. So, this is your answer. Okay? So, that is problem number 2. Now, in number 3, so this is actually a function where we are working with general term because the function y is expressed as u raised to power v, and your u and v are all functions, are differentiable functions. C and x, no? Now, using a power rule is not possible because under a power rule, the power of which must be constant. But I can use a logarithmic differentiation instead. Okay? Take the ln both sides and simplify. So, ln of y, ln of u raised to power v. So, your u is containing an exponent. The power can be taken as a factor. And I can differentiate once my u has a power which is already 1. Okay? Differentiate with respect to x, 1 over y prime for the ln y. And I can take the derivative of a product of VL in U. So, y prime is when I multiply with y both sides, that is y. Makita na to that our y is now expressed as a factor of the derivative of a product of VL in U. But what is y? It is u raised to power v. So, you have answer. The derivative of y or the derivative of u raised to power v is equal to the given function y, which is u raised to power v. Then I can take the derivative of v ln u. So, this is marked as D25. Actually, I'm deriving a formula for a function that is expressed as u raised to power v. So, in the next set of problems, no, then we will be discussing on how to use the D25. So how to differentiate when your function takes a form of u raised to power v. Okay, so thank you for watching and thank you for being with me. Okay, so bye-bye and good day.